Happy day for the viewers. This is Professor L. Nagarajan, working as an assistant professor in the Department of Electrical and Electronics Engineering in MAM School of Engineering, created by NAC, approved by AICT New Delhi, affiliated to Anna University, Chennai, Trichy. This is the graphical representation of action and resting potential. Okay, so this is the action resting potential and this is the action potential, and so when we are under resting, our cell voltage is in negative, and if you want to do some work, for example, all of a sudden we cannot if you want to make if we are in a running race, shall we start immediately to the 40-50 km per hour? No, we are starting from the zero. Okay, that is this point. Okay, and we are starting from 10-20. Okay, after it reaches some 30-40, again we will be taking the very high steps. Okay, that is nothing but the spike of the action potential. Okay, after the running is completed, we are not stopping as it is. Okay, we are not stopping suddenly. Okay, after we reach our end point, the person runs slowly, very slowly, and finally he will lay down. Okay, even that time also his heartbeat will be very high and he will be feeling so tired. Okay, after half an hour or 1 hour, after he take rest, his body will come to its original value. That is resting potential. So this is the graph. Okay, so from here it is to the action potential is depolarization, and from action potential to resting potential it is again repolarization. Okay, so this is the graphical representation of action and resting potential characteristics. Next we are going to discuss about the electrodes. What are the different types of electrodes and why these electrodes are utilized, and where the biopotentials are taken into the consideration to identify the problems in our body. Okay, so what are the electrical signals? First one we are going to discuss is a electrocardiogram. Okay, that is ECG. It takes place in the heart. Then electromyogram, it is EMG. It takes place in the muscles. And electroencephalogram, that is EEG, that takes place in the brain. Then electro-optogram, that is EOG, that is it happens in the dipole eye. Okay, next one is electroretinogram. Okay, it also takes place in the eyes. Okay, and electrogastrogram, EGG, it happens in the stomach. And finally galvanic skin reflex, GSR, it takes, that is it happens, it forms in the skin. Okay, surface of the skin. So these are the major electrical activity happens in our body. With these activities we will measure the waveforms, and with that waveform we can classify what is the type of problems that is taking place in our body. Next one is types of electrodes. So in the previous slide I had said the different types of electrical activity in our body. Okay, so we cannot use a single electrodes to pick all the electrical signals from our body. Okay, what you have to do is there are different portions, and for different part of our body different types of electrodes has to be used. Okay, so what are the different types of electrodes? First microelectrode, then needle electrode, then surface electrode. Okay, so microelectrode, it is as the name insists, it is a micro level electrode where it can take the electrical signals from a single cell. Okay, from a single cell. And there are two types of microelectrodes. One is metallic and another one is non-metallic. Okay, this is an important question repeatedly asked in Anna University, and for this we need to draw the diagram and equivalent circuit of the all to this microelectrodes, metallic and non-metallic. Now we are going to discuss about the metallic electrodes. So before going to that, See, when we look at the structure of both microelectrodes, that is both metallic and non-metallic, both resemble same. Only the difference is the enclosure. Okay, in metallic electrodes, the enclosure is made up of some metallic, that is metal materials, whereas in case of non-metallic, it is made up of glass. That is the only difference. Whereas the remaining, the material used will also be the same. And if you look at the equivalent circuit, it is also somehow similar. Okay, so here we are going to discuss about the metallic electrodes. So in these metallic electrodes, the tungsten filaments or the stainless steel wires are used to pick the electrical signals from the cells. And see, here we can find the equivalent circuit of this metallic electrodes. Okay, so next, this is the non-metallic electrodes, and as I said earlier, the enclosure is made up of glass. That is the difference between the two. So here you can see the glass is the enclosure. Glass is the enclosure. Okay, so this is the equivalent circuit